Our topic is the mean value theorem. The mean value theorem is a fairly simple and very intuitive math process. Let's get started here. Suppose f is continuous on the interval a to b and differentiable in between. That means that there exists some argument c, such that there is a tangent slope, also known as a derivative, somewhere on this curve equal to the secant slope. Now, so you can see right here, I'm going to draw the tangent slope that I think is probably equal to the secant slope. Another way to think about this would be that the secant slope, also known as rise over run, right, has an equal tangent slope at some point c. Right, so this is the rise over run of our secant slope, which is equal to where I pointed at on that point C. The funny thing about the theorem is that it doesn't necessarily give a route to solving the problem. So let's go ahead and look at an example. So here we have the graph of f of x is equal to x squared. And for this specific example, we'll set the interval from 0 to 1. Now we have to clear a couple things, make sure that, as you can see, it's continuous, and therefore it is differentiable on said interval. Next, we'll go ahead and calculate our secant slope, which is going to be f of 1 minus f of 0 over 1 minus 0, which comes out to a secant slope of 1. Let's also make sure to note that we can kind of intuitively grab that derivative from f of x equals x squared to f prime of x equals 2x. So when we set our derivative equal to our secant slope, we have f prime of x is equal to that f of 1 minus f of 0 over 1 minus 0. Meaning 2x is equal to 1. We'll solve for x and we have an x-intercept of 1/2. This means that at x equals 1/2, our secant slope from within that interval is equal to the tangent slope, right? The tangent slope at x equals 1/2 is equal to that secant slope. Now let's go ahead and try one without the graph in our face. We're given an equation of f of x is equal to negative x squared plus 6x minus 3, right? And we need to find c on that interval. So we'll start out with finding our rise over run or our secant slope. To do this, we'll start by solving for f from the points given on our interval. So f of 0 equals negative 0 squared plus 6 times 0 minus 3, which equals negative 3. Then we have f of 4 equals negative 4 squared plus 6 times 4 minus 3 comes out to 5. From here, we can set up the equation that we want to finish with, which is f prime of c is equal to that rise over run, f of 4 minus f of 0 over 4 minus 0, which comes out to being 1, a slope of 1. Now, over here, let's find our derivative or our tangent slope from the equation given. So we'll start with f prime of x is kind of intuitively equal to negative 2x minus 6. So finishing setting up our equation, we have f prime of x is equal to that rise over run, f of 4 minus f of 0 over 4 minus 0, which we know now is negative 2x minus 6 being set equal to 1, which when we solve for x comes out to negative 2x equals 6, and then x equals negative 3. It's important to note that most of the time x and c are the same thing in these equations. C equals negative 3 on our theoretical graph. And that is the basic rundown of the mean value theorem. When we apply it, we're really just trying to find out where our secant slope, right, that rise over run kind of theoretical slope of the curve, is equal to the tangent slope of the curve. At what x value or values is our tangent equal to our secant?